Greetings, friend, and welcome. For most of history, wildfires were discovered when someone saw smoke, reported it, and firefighters responded. Fire towers, lookout crews, aircraft patrols, and emergency calls have been the backbone of wildfire detection for decades. AI is changing that model by watching continuously instead of waiting for someone to notice. Modern wildfire detection no longer relies on a single technology. AI combines fixed cameras, satellites, drones, weather stations, lightning data, infrared sensors, and ground-based environmental sensors. Instead of replacing existing systems, AI connects them into a single monitoring network. Companies such as Pano AI have installed high-definition camera networks on mountaintops and existing communication towers. These cameras scan the horizon every few seconds, with AI analyzing each image for smoke columns. When smoke is detected, the system alerts human operators who verify the event before notifying emergency agencies. The goal is to detect fires before they grow from meters into kilometers. Orbiting satellites constantly capture thermal and visual imagery across continents. AI analyzes these images for heat anomalies, smoke signatures, and changes in vegetation. NASA's MODIS and VIIRS instruments have long been used for wildfire detection, while newer systems provide increasingly frequent updates. Instead of waiting for daily imagery, many regions can now receive updates multiple times each hour. Google Research and Google DeepMind developed FireSat and related wildfire prediction systems designed to identify fires as small as roughly 5 by 5 meters, significantly smaller than many existing satellite systems can detect. Google has also developed AI models that forecast how fires are likely to spread by combining satellite imagery with terrain, vegetation, and weather conditions. AI is beginning to answer not only where is the fire, but also where will it be next? But AI isn't only watching forests anymore, it's beginning to listen to them as well. Some detection systems use acoustic sensors, environmental microphones, and sensor networks to detect unusual sounds or environmental changes associated with wildfire ignition. Other systems combine temperature, humidity, smoke particles, carbon monoxide, and wind measurements into AI models that identify abnormal conditions before large flames develop. Once a fire has been found, the next challenge is understanding it. Drones equipped with thermal cameras can rapidly map fire edges, identify hotspots hidden beneath smoke, locate trapped civilians, and provide firefighters with real-time aerial intelligence. Several systems increasingly automate flight paths, image analysis, and hotspot identification using onboard AI. Researchers are training AI on decades of wildfire history, alongside weather, drought conditions, fuel moisture, vegetation density, topography, and wind forecasts. These models estimate where fires are most likely to ignite and which regions face the highest risk before any smoke appears. The United States, Canada, Australia, and multiple European countries are integrating AI-assisted detection into national and regional wildfire management. California has expanded AI camera networks through ALERTCalifornia. Europe's Copernicus Emergency Management Service combines satellite monitoring with predictive fire mapping. Emergency operations are increasingly receiving AI-generated alerts alongside traditional reports. Longer fire seasons, higher temperatures, prolonged droughts, and expanding wildland-urban interfaces mean fires spread faster than in previous decades. Minutes can determine whether a fire remains a local incident or becomes a multi-billion-dollar disaster. AI's greatest advantage may simply be time. Current systems still rely heavily on human verification before dispatching emergency resources. False positives remain possible because smoke, dust, fog, clouds, industrial emissions, and even insects crossing camera lenses can resemble wildfire signatures. AI serves as an early warning system, while experienced firefighters and emergency operators still make the final decisions. The same AI infrastructure being built to detect wildfires is increasingly overlapping with systems that monitor floods, hurricanes, weather, biodiversity, air quality, infrastructure, agriculture, and environmental change. forests are becoming places continuously monitored by intelligent systems that never sleep, combining cameras, satellites, sensors, drones, weather models, and predictive AI into something resembling an environmental nervous system. If AI can detect fires before humans see smoke, predict where they will spread, and continuously watch millions of acres around the clock, are we simply building better firefighting tools? Or are we witnessing the birth of an AI that watches the natural world continuously? This is Micah Sai, keeping you up to date on technology that will rule your future. Subscribe for more.